Good afternoon, friends. Our today's discussion point is about the power transmitting elements. Normally, it is called as mechanical drive. So, power transmitting elements are normally used to transmit the power and motion both. Power and motion both from one shaft to another shaft. As we have discussed in the previous lecture, that clutch, brakes, and couplings are normally used, and couplings are normally used to connect the two shafts. And specifically, uh, we have to transmit the power from one shaft to another shaft by means of the mechanical drive. For that, you have to keep in mind about the fundamental elements of power transmitting systems are holding and joining element like nut, bolt, coupling that we already discussed about the coupling, how couplings are coupled together and holding two shafts together during the power transmitting process. Also, we have driver shaft and driven shaft. In this topic, we have to study about the mechanical drive, like belt drive, chain drive, and gear drive. That is the fundamental aspect of discussing about this today's topic. Okay, and supporting element like bearing, how bearings are used to support the load and motion so that we can withstand the vibration during the power transmitting system or power transmitting work. So, main focus of today's topic is about the mechanical drive. As we already discussed about the coupling, clutches, and brakes in the previous lectures. So, the mechanical drives are of three types: belt drive and rope drive, in which we have to use the belt and rope. Also, we have to use the chain like sprocket, and gear drive, that is the positive drive by engagement of the teeth of the gear. Okay, including the gear trains. So one by one, we have to discuss about the each and every element in the brief, so we can easily understand about how it can be helpful to elements of mechanical engineering understanding. The belt drive is normally used for the shorter distance. Just have to see here, we have to use for the shorter distance belt drive, and it is the negative drive as slipping is possible. Slippage due to friction between two mating surface, that is the belt is normally wound around the pulley drum. So external surface of the pulley and bottom surface of the belt is in contact with each other, and during the tightness of the bearing, the pulley is transmitting the motion from one pulley to another pulley, i.e. Driving pulley to driven pulley. But here there is a chances of a belt over the pulley, so it is generally considered as the negative drive, and some losses of the friction are always there. So here two types of belts are used in the belt drive. We have the flat belt and V belt. Okay, so flat belt is most commonly used machinery element transmitted the power with center distance less than 8 meters. If two shafts, suppose shaft 1 is this and shaft 2 is this, and power, we have to transmit the power from one shaft to another shaft, then you have to wound the pulley over the two shafts. But you have to keep in mind is that the center distance between these two shafts should not be more than 8 meters. That is the ideal requirement of using the belt drive, or specifically flat belt drive. Okay. Similarly, V belt is also used in the machinery to transmit the power for the shorter distance, but it is more positive. The main advantage of V belt over the flat belt is what? V belt is more positive, means there is a less chance of slippage in V belt compared to the flat belt. So that is the thing why we have to use the V belt. Now you have to keep in mind a little bit. This is the pulley surface. This is the pulley surface, and you can see bottom contact is there. Bottom of the belt is in contact with the pulley surface. But in case of V belt, you have to keep in mind is that there is a side contact. Instead of bottom contact, there is a side contact. So that is the fundamental difference between the point of contact between the flat plate and V belt that you have to keep in mind. Okay. This is about the configuration of the flat plate and V belt. Then, depending upon the power, motion, we have various types of the belt drive where open belt drive is there. So here you can see open belt drive is there. Very simple thing is there. This is the driving pulley. This is the shaft. Shaft is fitted with the pulley over the shaft. This is the driven pulley and belt is cycling. So rotation is like this, clockwise rotation. So driven pulley rotation is in the same direction for the open belt drive. And this is the tight side where tightening is on this side. And this is the slack side of the belt. And top view is looking like this. This type of belt drive is normally used when driver shaft and driven shaft is rotating in the same direction. Suppose if it is rotating in opposite direction, then what we have to do? We have to use the cross belt drive. Instead of open belt drive, we have to use the cross belt drive. So here you can see crossing of the belt is there, where driving pulley is rotating in clockwise direction, but you need the rotation of the driven pulley anti-clockwise. Then you have to cross the belt. So that your right side is this, slack side is this, and configuration viewing from the top is like this. So this is about the open belt drive and cross belt drive, depending upon the requirement of the motion, opposite or in the same of the driver shaft. And compound belt drive is also there, in which distance between driving shaft and driven shaft is more. Normally what happens, we have to use the belt drive limited to 8 meters. Ideally it is 8 meters, but if length is more and we have to compulsorily go for the belt drive, then you have to add the intermediate pulley. Then you have to add the intermediate pulley like this. Just have to see, this is the intermediate pulley. Like this. Multi-intermediate pulley can be attached, where there is no role of this intermediate pulley. This is your driving pulley, and this is your driven pulley. Only objective of intermediate pulley is to provide the support so that more than 8 meters large distance can be covered for the purpose of transmitting the power through belt drive. So this is the main function or main concept of the compound belt drive that you can refer. I will share you this slide to you so you can easily refer. Now quarter turn. Just have to see the quarter turn belt drive. The quarter turn belt drive we use according to the figure. You can easily see that when two shafts are right angle to each other. So this is the vertical one. Just you can see here. This shaft is vertical one. This shaft is vertical. Line of action is vertical one. And this shaft is line of action is horizontal one. Just you have to see. And this is the vertical one. So two shafts are right angle to each other. At that time, you have to use the quarter turn belt drive. You have to simply wound the belt crossly with the pulley of the driving pulley with the driven pulley. So according to the arrangement, you can easily see how we can use a different kind of the belt drive. Also, we have to use the belt drive by means of the idle pulley. So idle pulley normally used like this, and normally it is used on the slack side of the belt, where there is a chance of the slack, and due to slack, uh, the strength of the belt is to be affected. Okay, so to provide such kind of slacking, we have to use the idler pulley simply to provide the support over the belt. Then fast and loose pulley. Now fast and loose, as we already discussed about the coupling, you know about the coupling. Now fast and loose pulley is nothing but the coupling, in which Just have to see. We can easily change the belt like coupling. So fast and loose pulley is used to engagement or disengagement of the drive pulley with the driven pulley without use of the clutch and without stopping the driver pulley. According to the operator's wheel, same function like clutch. The primary objective of this is to use same driver shaft for different machinery. So here you can see fast pulley is there. This is the fast pulley and this is the loose pulley. You can see two pulleys are there and this is the machining shaft. Okay, and this is the driving shaft. So driving shaft remains same. Here many machine shafts are there. Fast pulley, loose pulley is there. Okay, so what you have to do by means of this arrangement, by means of this mechanism, you can simply shift this belt from this shaft to this pulley, so that now driving shaft can run fast pulley, and when you have to shift this belt over this loose pulley, then driving shaft will run loose pulley. And we have to wound this belt over the loose pulley, then what happens? There is a disengagement of the driving pulley with the machine shaft. So machine shaft is basically fast pulley and loose pulley is idle pulley. So it is the, simply we can call it as the disengagement of the driving shaft with the driven shaft. And again, when you have to require the power transmission, then you have to shift this belt to the fast pulley from the loose pulley. So this is very simple arrangement of the fast pulley and loose pulley arrangement in accordance with the performance of the clutch. Also we have gone or step pulley is there. So a step pulley drive is there. You can see here. On or step pulley is used to vary the speed of the driven shaft. Normally this kind of thing is majorly now in nowadays by used by means of the different gearbox, like we are using the gears, gear number 1, gear 2, gear 3 and so on. Depending upon the speed we can simply change in our automobiles. So that is easily possible in gearbox by means of the gear drive, but same can be available by means of the stepped or different kind of the pulley. So here you can see the driving shaft is this one. This is the driving shaft and this is the driven shaft. So what you have to do is you have to uh, make the different combination of the pulley, driving shaft and driven shaft, so that depending upon the velocity ratio, we can alter the speed of the driven shaft in accordance with the driving shaft. Okay, so we can vary the speed of the driven shaft by changing this belt for the different pulley. Okay, so velocity ratio can be changed. Velocity ratio is equal to speed of the driver to the speed of the driven. That I will show you in the upcoming section, so you can easily see. Velocity ratio is considering the smaller pulley as driver and larger pulley is driven, rotating anti-clockwise. You can see tight side and is on upper side as it is rotating anti-clockwise as shown in the figure, and slack side on the bottom side. So what is the speed? Diameter is d1, speed is n1, diameter is d2 for the driven, and speed is n2. Then velocity v1 is equal to pi d1 n1, and linear velocity of driven pulley v2 is equal to pi d2 n2. As both the pulleys are connected with belt and rotate at same speed, so v1 is equal to v2, as both the pulleys are rotated at the same speed according to the figure. So v1 is equal to v2, so pi d1 n1 is equal to pi d2 n2, and from this n1 by n2 is equal to d2 by d1, where nothing but n1 by n2 is called as the velocity ratio, speed of the driver over the speed of the driven. So if you vary the speed of the driven, then velocity ratio can be changed. So for that, n1 by n2 is equal to d2 by d1. So inversely proportional to the diameter of the pulley. So what happens here? Suppose you have to increase the velocity ratio. Suppose you have to increase the velocity ratio. Then what happens? Either you have to, suppose you have to increase. Suppose your speed is constant, but If you have to increase the velocity ratio, then what you have to do? You have to increase the d2 or you have to decrease the d1. Okay, so this fundamental can be used over here to change the velocity ratio in the previous section that I will explain you in the step or pond pulley, where diameter of the pulley is to be changed here. Just have to see diameter of the pulley. We are changing the diameter of the pulley. We are not changing the speed. So by changing the diameter of the pulley D1, say D2, say D3, say D1, D2, D3, likewise. Okay. So by changing the diameter of the pulley, we can achieve different velocity ratios. Different velocity ratios means different speed of the driver driven with respect to driver. So that is the use of the belt in one pulley arrangement. So velocity ratio to keep in mind is that speed of the driver divided by speed of the driven pulley, or inversely proportional to the diameter of the pulley. So speed velocity ratio is the diameter of the driven pulley divided by diameter of the driver pulley. Diameter of the driven pulley on the upper side. So in compound belt drive like pond pulley, what you have to do? We have the speed of the last driven divided by speed of the first driver. Okay, speed of the last driven divided by the speed of the first driver. Okay, velocity ratios. So in compound belt drive, you have to keep in mind. So product of the diameter of the all driver divided by product of diameter of the all driven or driven by driver. Vice versa. So speed is inversely proportional to the diameter of the pulley here. Now ratio of the belt tension. As we already discussed that we have some tight side and slack side. Suppose you have to assume that tension on tight side is T1 and tension on slack side is say T2. Then what is the ratio of T1 by T2? That is helpful for calculating the example. So here you can see one figure, magnification of pulley where belt is in contact with this and where belt is in contact with this thing. So here you can see this is the line of action of the or line of the contact. Assuming theta, small angle where belt is in contact is d theta, delta theta. So this is the normal reaction according to against the frictional force F is equal to mu into R. As you know about the frictional force theory, F is equal to mu. Mu is the coefficient of friction into R. R is the normal reaction perpendicular to the frictional force. So friction force is like this or like this, depending on the rotation of the. Suppose it is rotating anti-clockwise, and friction force is like this. If it is rotating clockwise, then friction force is like this. There is F is equal to mu into R, and this is d theta. So d theta by 2 or delta theta by 2 like this. Now we have to find out the ratio of two tension T1 by T2. T1 by T2. Okay. So T1 by T2. How we can find out? That I will explain you here. Very simple thing is there. You have to mathematically resolve these things. T, this is T, total T, this is T plus delta T, this is T1 and this is T2. So T is there, T2 is there, T plus delta T is there, and T1 is there. Force acting on the belt. Resolving the force vertically. So R is vertical one, and sine component of T, sine the delta theta by 2 plus T plus delta T sine delta theta by 2. So resolving the force vertically. Just you can see this figure, resolving the force vertically. Vertical component of this T and T plus delta T with respect to delta theta and R. And resolving the force horizontally resolving the force horizontally, simplifying first. T into sine is sine 0 0 and delta theta is very small. So sine delta theta we are considering it as 0. So sine 0 0 means 0. So instead of sine delta theta by 2 we are putting delta theta by 2. We are avoiding the sine because sine 0 is 0, sine theta is theta. If theta is 0. So here delta theta by 2 is considered as equal as 0. Okay, so t into delta theta by 2 plus t plus delta t into delta theta by 2. Okay, and simplifying this term and removing the small terms, this multiplication becomes more and more simple. So only we have t into delta theta, t into delta theta. Okay, now resolving the force horizontally. Mu into r, F is equal to mu into r is equal to t plus delta t cos component minus t into cos delta theta by 2. So t plus delta t minus t as cos theta is equal cos 0 is equal to 1. So d theta by 2 is very small. So this we are considering it as 1 and this we are considering it as 1. So ideal figure is t plus delta t minus t. Removing the delta t, removing the term t, will get delta t. Horizontal mu r is equal to delta t. Then r is equal to t delta theta, mu r is equal to t. So put this equation number 2, equation number 1 as we have achieved by means of resolving the force vertically and put r in here. This r. So mu into t into delta theta is equal to delta t. Okay. Very simple mathematics is there. Then delta t by t, rearranging the term delta t by t is equal to mu delta theta. So integrating delta t by t, t1 to t2. Our tension is from t1 on right side to t2 on left side. Integration mu delta theta. Integrating will be converted into ln. T1 by t2 is equal to mu theta. So T1 by t2 is equal to e raised to mu theta. So that is the equation that you have to keep in mind. Derivation may not be asked, but you have to keep in mind about this equation. Ratio on tension, ratio of belt on tight side, ratio of tension on belt on tight side over the slack side is equal to e raised to mu theta, where mu is the coefficient of friction and theta is the angle at which belt is to be connected, contact angle. Okay. I plus or minus 2 alpha and sine alpha is equal to d1 plus d2 by 2c, where c is the center distance, d1 is the diameter of the pulley, driver pulley, d2 is the diameter of the driven pulley, and c is the center distance between the pulley. From this configuration, you can easily find out alpha, use that alpha to find out the theta. So this is the another thing that you have to keep in mind for solving the problem. Okay. Then power transmitted by the belt. How much power is to be transmitted? Now, fundamental equation of power transmission P is equal to T1 minus T2 into V divided by 1000 in kilowatt. Power P is equal to torque into velocity. Torque means moment, moment into velocity. That is the simple power definition. Okay. So T1 minus T2, where T1 is tension on tight side, T2 is tension on slack side. So net torque is T1 minus T2 into V. V is the velocity at which the pulley is to be rotated. Where V is equal to pi dn by 60, where d is the diameter. And if n is given in RPM, then you have to use V is equal to pi dn by 60. So this is about the shaft. Two parallel shaft, 2 meter apart. So C is given. Flat belt drive is used. Pulley of diameter 450 D1 and 150 D2 is given. The belt transmit 25 kilowatts. So power is given. RPM N is given. So we have to determine the tension on right side and slack side. So T1 and T2 we have to find out. Mu is given. So how to solve the problem? C is given. So convert it into single term. 2000 mm D1 is given 150, smaller is driver, so we have to put it as D1 smaller, D2 driver, D1 that is bigger. Ideally, you can take it as like this. Power is given. Now D1 and D2 we have to find out. So V2 is equal to pi D2 M2 by 60. First of all, you have to find out V2. Alpha is equal to D1 plus D2 by twice C. So first of all, you have to find out the angle of contact alpha, and theta angle, included angle theta is equal to pi plus 2 into alpha. So in degree and convert it into radian. D1 by T2 is equal to is to theta. Use this equation to find out the ratio. Okay. And P is equal to T1 minus T2 into V. V2 already you have find out. Power is given. So T1 minus T2 is there you have. So you have T1 minus T2. You also have T1 upon T2. And solving this two will give you T1 and T2 both separately. So this is the way how you can easily find out the power on right side and tension on right side and tension on slack side for the belt drive. So this is about the fundamental of the belt drive. Clear? Now rope drive. In rope drive, what you have to do is it is similar like V belt drive. Instead of V belt, we are using the rope drive, and you can see here in this figure side are in contact with the pulley drum. So it is in circular motion, whereas V belt is in rectangular motion. Now rope drive is why we have to prefer the rope drive. Rope drive is basically used to transmit the large amount of power, comparatively large amount of power, with distance between the shaft are more than 8 meters. Normally belt drive is restricted to 8 meters. However, we can use intermediate pulley to transmit the to achieve the long distance. But rope drive can directly use more than 8 meters. Okay, so it is specifically suitable for large uh, distance power transmission. And ropes are basically a fiber rope or wire rope. You can see fiber rope is suitable for light application, whereas wire rope, metal ropes are normally used for heavy duty application like cranes, hoist. Hoist means lift or elevators. Normally we are using the wire rope. You can easily see in your domestic lift about such kind of wires. So there are nothing but the rope drives. Okay, so this is about the rope drive. Simple thing is there. And then chain drive, in which chain is normally rope drive and belt drive are, however, little bit negative, and certain laws of power is always there because of the friction or slippage. So friction laws are always there. But in case of chain drive is possibly positive drive and mostly used for the shorter distance. Normally we are using this chain drive in cycle or in two-wheelers like bike, specifically bikes, automobile vehicles. Okay, in which you have to keep in mind about the chain and sprocket. Driving sprocket, preferably driver are smaller in diameter, that you have to keep in mind whether it is going for the belt drive, gear drive or chain drive. So driving sprocket instead of pulley, sprocket means having some teeth over it, a kind of plate is there, and driven sprocket. Okay, so a kind of chain is there, and it is positive drive and normally used for the shorter distance. Now one of the most important thing is gear drive. Gear drive is positive drive, there is no friction takes place, and it is one of the most commonly used drive for basically all type of mechanical machinery including automobile vehicles. And this is about the gear, how gears are to be identified. The gear drive is transmitting the power when both the gears tooth gear tooth on driving pulley or driving gear plane over the gear tooth on the driven pulley is to be meshed with each other to transmit the power. So meshing, for meshing purpose you have to keep in mind some terminology like gear teeth. This is the face width of the gear. That is one of the most important element for designing the gear. That is not part of your syllabus. Upper circle is called as the addendum circle, passing from the top of the gear teeth. Passing from the center of the gear teeth is called as the pitch circle. Normally, all basic parameters are to be measured over the pitch circle, like circular pitch. Just have to see point on one point on the gear to the same point on the adjacent gear. Circular pitch, total dip is from the top to bottom. Upper portion is called as the face, lower portion is called as the flank. Okay, and tooth thickness you can see measured over the pitch circle at the center. That is the tooth thickness. So fundamental difference between circular pitch and tooth thickness. And you can see end of one gear to the start of the adjacent tooth. Next tooth is called as the tooth space. Space between the two gear tooth. So this is some basic terminology of the gear that you keep in mind for easy understanding of the gears. Now, some explanation is there. Pitch circle is the imaginary circle passing at the mating of the two gears. Addendum circle is the upper side circle. Addendum circle is the lower circle. Addendum and addendum is there. Face I have shown you. Total depth I have shown you. Total space. Just have to see. Diametral pitch is the ratio of the number of teeth or to the pitch circle diameter. That you have to keep in mind. Circular pitch PC is equal to pi into m, and m is the module inverse of the diametral pitch. So module, diameter pitch, and circular pitch. That is one of the most important parameters for consideration of the gear design. That is actually not a part of the syllabus at that time. For mechanical student, it can be covered for machine design subject in upcoming semesters. And here you can see we have the velocity ratio same like speed of the driver to the speed of the driven. Circular pitch is the distance measured on the circumference of the pitch circle passing imaginary circle passing through the center of the gear tooth. So distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on adjacent tooth or next tooth. And pressure angle is the angle between pressure line and common tangent to pitch circles. So two pitch circles are there when two gears are matching to each other. Okay, so this is about the simple terminology of gear. Now we have basically four types of gears are there. Whereas per gear you can see the number of teeth are joined like this and they are in rotation to each other. Here one point you have to keep in mind is that the rotation of both the gears are normally considered as in opposite direction. Okay, so spur gear is there, rack and pinion type of gear is also there, where one is gear and one is the horizontal pinion. Normally in certain applications rack and pinion kind of gears are used, like drilling machine, measuring instruments, or lathe machine. Normally these kind of things are used. Basically, spur gears are widely used, specifically in automobile. This is about the simple gear, spur gear, rack and pinion, and helical gear is this nothing but the modification of the spur gear where gear teeth are not exactly in line, but they are inclined to the gear teeth. So some inclination is there. In spur gear, what happens? This gear teeth is like this, straight. But here we have provided some inclination. So that inclination angle with respect to straight line is called as the helix angle. So this is helical gear. So it is called as the helix angle. So, and main objective of using the helical gear over the spur gear is that helical gear will provide the better power transmission or strong, or we can call it as more capacity of transmitting the power over the spur gear. So how the spur gear is, you can see from this figure. Very simple teeth is there, and same teeth is to be inclined at an helix angle. So that is the fundamental difference. Then bevel gear is like a power transmitting when two gears are at any angle, specifically 90 degree. Okay. So automobile gearbox, normally in all automobile vehicles, four-wheelers specifically, we are using the bevel gears. Differential gearbox you can see at the bottom of the your car. You can easily see this. And fifth one is the worm and worm wheel. So worm is normally used here. This type of gear, as you can see, worm is there and worm wheel is there. And power reducing. These gears are specifically used for power reduction, where output speed is comparatively you need less than input shaft for driving shaft. If driven shaft speed is less, then you have to go for the worm gear. And comparison of these three drive is belt drive, chain drive, and gear drive is there here listed. So for belt drive, main element of the belt drive are belt and pulley. Main element of the chain drive are chain, sprocket, etc. And for gear drive, pinion and gear, where pinion is the driver and gear is the driven. Chain drive is negative, sorry, positive drive. Gear drive is positive drive. Belt drive is negative. Now here you can see belt drive is large in size and suitable for longer center distance between up to 8 meters. Chain drive is normally medium in size and suitable for moderate center distance, comparatively less center distance than belt drive. And gear drive is very compact and suitable only for shorter distance. Long, moderate and shorter distance. Short life with low cost, medium life with cost, and long life with high cost. Okay, so normally we are using the gear drive in automobile engines. Velocity ratio is low as slippage is more, medium velocity ratio, and here very high velocity ratio. And first drive transmission, this is normally used in bicycle and wheelers. This is mostly used in heavy machineries, machine tools, and automobiles. This is the comparison of the three mechanical drives about the power transmitting elements.